Hello everyone, welcome back to my YouTube channel. As you all know, this is Kavya from Sri Venkateshwar College of Engineering, pursuing my second year BE in the Department of Electronics and Communication. And here my subject is network analysis. After a long bit time, here I am back with a new topic, that is classification of electrical networks. First introduction in this, let we'll know about what are electrical networks. An electrical network is an interconnection of electrical components, example batteries, resistors, inductors, capacitors, switches, transistors, or a model of such an interconnection consisting of electrical components, example voltage sources, current sources, resistances, inductances, and capacitances. And also, an electrical circuit is a network consisting of a closed loop giving a network return path for the current. Thus, all circuits are networks, but not all networks are circuits. Although networks without a closed loop are often imprecisely referred to as circuits. In the picture, we can see the electrical network diagram. And next is classification of electrical networks. These are classified based on type of sources. First one is based on presence of sources. In this, first one is active networks and passive networks. Second one is based on direction of current. In this, first one is bilateral network, second one is unilateral network, and third one is based on separability. In this, first one is lamped network, second one is distributed network, and fourth one is based on linearity. In this, first one is linear network and second one is non-linear network. We'll know about first one, that is based on presence of sources. In this, first one is active network. An active network is a network architecture that allows for the modification of network operations by packets flowing through the network. It's a new packets flowing through the network. It's a new approach to network control that all allows for the construction of functionalities to be applied to packets inside the router. An active network in electrical systems is a network that has at least one source of voltage or current that can supply energy to the network indefinitely. A battery or a generator are example of active sources. In the picture, I had given the active network diagram, and second one is some key features of active networks, that is programmable. Active networks all allow users to inject customized programs into the network nodes. Overlay networks. Active networks can be implemented as overlay networks, where the active network consists of active nodes that perform user-defined processing on user data. Active hardware. Networks include active hardware that can route or switch and execute code within active packets. And fourth one is execution environments. Active network architecture includes execution environments which are similar to a Unix shell that can execute active packets. And we'll know about what are passive networks. A passive network is a network that uses unpowered devices and components to transit data and signals. Passive networks are often used in fiber optic networks such as passive optical networks (PONS) and are made up of components like cables, connectors, and splitters. In the picture we can see passive networks. And here some characteristics of passive networks. Unpowered. Passive networks don't require any electrical power to transmit signals. And static. Passive networks are more static and predetermined than active networks, which can make them easier to manage. And third is cost effective. Passive networks are simpler and most cost effective than active networks because they don't use active electronic devices used with active equipment. Passive network components are often used with active routers, switches, or hubs to build a complete network. And next is based on direction of current. In this, first one is bilateral network. A bilateral network is a circuit or network that has the same behavior and characteristics regardless of the direction of current through its elements. In a bilateral network, the current's magnitude remains the same even when the voltage polarity is reversed. A linear bilateral network is a type of bilateral network where the components have a linear relationship and the current's magnitude is independent of the voltage's polarity. A circuit or network made up of only independent sources and resistors is an example of linear bilateral network. And in this, second one is unilateral network. A unilateral network is a circuit that behaves differently depending on the direction of the current flowing through it. The current in a unilateral network only flows in one direction. Examples of some example of unilateral networks. Diodes. A diode is a unilateral circuit element that only allows current to flow in one direction. A p-n junction diode only conducts when the p region is connected to a higher voltage and the n region is connected to a lower voltage. Transistors. Transistors are another example of unilateral circuit. In the picture we can see the circuit or network of unilateral network. And next is based on separability. In this, first one is lumped networks. A lumped network is a network where all elements are physically separable and is often a simplified version of a distributed network. Lumped networks are useful in many areas including electrical systems, mechanical systems, heat transfer and acoustics. For example, most of the electrical circuits, passive network, a circuit which contains no energy source is called passive network. Two types of voltages are used. One is alternating current and direct current. In here we have see the diagram of lumped network. And next one is distributed networks. A distributed network is a network architecture where data and computing resources are spread across multiple nodes which work together as a single network. It's also known as P2P network or a decentralized network. For example, telephone and cellular networks, the internet, blockchain, secure access service edge, that is SASE, edge computing for IoT, and silent server distributed networking. Here we can see the diagram of distributed network, and let we know based on linearity. In this, first one is linear network. A linear network is a network where the resistance of each component remains same regardless of the current value. This network exhibits constant parameters, that is resistance and inductance. In other words, these parameters do not change with the changes in voltage or current. Working through a linear network is simpler than one might think due to its consistency of characteristics. Here second one is nonlinear network. A nonlinear network is a circuit or network that contains at least one nonlinear element, not including independent sources of voltage and current. For example, diodes, transistors, thermistors, Zener diodes, iron core inductors and transformers, mixers, modulators, rectifiers, radio reservoir detectors and digital logic circuits. Digital logic circuits, these circuits operate in non-linear way. Here in picture we can see the non-linear network. And next is some advantages of classifying electrical networks. Detecting and classifying power quality events. Method for classifying power quality events, that is PQDS, can be used to identify disturbances such as sags, peaks and harmonics. A confusion matrix, that is CM, can be used to evaluate the performance of a classification algorithm by comparing the predicted class labels to the actual class labels. And here second one is analyzing electrical networks. Linear electrical networks can be analyzed using frequency domain methods to determine AC and DC and transient response. Resistive networks can be analyzed by modeling their graph measures and geometrical properties. Quantifying the behavior of electrical generation systems. Performance indices can be used to quantify the behavior of electrical generation systems with different architecture or scalability. Thank you guys for watching my video. Please like and subscribe. Thank you.